For this video, I'm going to demonstrate how to use Stata to conduct an independent samples t-test. And to illustrate this procedure, I'm going to use the growth and enhancement for Montana students data that we've obtained from the Office of Public Instruction in Montana. And so you can see that data set is open, and we're going to browse that data just a little bit here. And we can see that we have our different categorical variables and then followed by a set of interval level variables like the criterion reference test in math, reading, and then we also have ACT scores that are taken in the 11th and 12th grade. For this example, what I want to do is compare male and female ACT math scores taken at grade 11 and determine if males and females differ significantly on those mean ACT scores. But prior to doing that, one of the things we need to do is to check the assumptions for the t-test. One of the assumptions is that the variables are normally distributed, and the second assumption is that the group variances are equal, so that they're, in other words, they're not significantly different from one another. So to do that, the first thing we might want to do is a histogram of these ACT grade 11 math scores. And we might want to look at that by gender. Okay, so then we can go submit. And we see that we have the male ACT 11th grade math scores here and the female math scores here. They're very similar in their distribution. They both have pronounced peakedness in the data, and otherwise they look fairly normal. But we really need to be more precise about making a judgment about normality. So what I'm going to do is save these graphs. To my desktop and close them out. And then what I'm going to do is a normality test by each group to determine if these data are significantly non-normal. So I can go to statistics and summary and then distributional plots and tests, and then I'm going to go to the Shapiro Wilks test. And in this case, again, I want to choose ACT Math 11th grade. And I also, again, I want to look at these distributions by each group. So I'm going to go OK. And we can see our results from our Shapiro-Wilks test here. And the Z tests are definitely significant. So what this means is that the data are significantly non-normal. And I would suspect that it's probably due to that peaked data, that bimodal data. The other thing that we want to do before we proceed with the t-test in order to check an assumption is to check the equality of variances. And we can do that again by going to summary, and we can go to classical tests of hypotheses and then variance comparison test. And again, we're using a two-sample or independent samples t-test, and the variable that we're comparing groups on is the math 11th grade ACT, and we're using gender. And so then we can submit that, and we can see that there's 144 males, 156 females. This is the mean for males, 22.18, and the mean for females, 21.07. And then we can see that the variances here are looked at, and they really report the standard deviations, but if you square those standard deviations, you get a variance. And so what we're looking at is to see if these variances are significantly different. And when we look at the middle portion of this output, this is for a two-tailed test. We're not saying that the ratio between the male and female variances is greater than 1 or less than 1. We're just wanting to know, are they significantly different? And here we can see that our probability is 0.3023. So this is much greater than 0.01. So this is a non-significant result. So we've satisfied the assumptions of equality of variances, but the assumption of non-normality has been violated. However, according to Hopkins and Glass, and if we read Aycock's book on using stata, we can see that if we violate one of these assumptions, that's not going to be a problem when we conduct our t-test. However, if we were to violate both assumptions, then we would want to use a non-parametric procedure like the Mann-Whitney U, perhaps, to compare male and females on mean ACT 11th grade math scores. But we're going to go ahead and do the t-test, and we can go to summaries, tables, and tests again, classical tests of hypotheses, and then t-test. And again, we want to pick toSample, which is for the independent samples t-test. And then again, the ACT math 11th grade. And then our grouping variable is gender. And so we can go OK, and then we get our result. So here we see again 144 males, 156 females, and the mean difference between males and females is 1.1, and the standard error is 0.54. Okay, again, because our research question that I implied was, do males and females differ on mean 11th grade ACT scores? And so in this case, again, we're going to use this middle region to read that. And what this tells us is the probability is 0.04. So this is below 0.05. So what we can interpret from these results is that it's significant. In other words, that this mean difference of over 1 point average in ACT scores between males and females is significant, and males are scoring, in this case, significantly higher than females on the ACT math score for 11th graders. We can also see that when we look at this portion of the output, HO is considered the null hypothesis, which means no difference, and then HA is the alternative hypothesis, which means there is a difference. So we also see the 95% confidence interval. And one of the things we can see from that is because the 95% confidence interval captures this 1.11 difference between males and females, then we see that that also indicates that the difference between males and females is significant.